This is Jack Jackson. We're going to continue our examination of what happens when we compose two isometries. We're going to get another isometry. Isometries are either reflection, translation, rotation, or glide reflection, or the identity transformation, but composing the identity transformation with something just doesn't change it. So we have 16 combinations of choosing the first isometry and then the second one. In the last video, we did all the combinations where we chose a reflection first and then went through the different cases and subcases here. In this video, we're going to talk about what happens if we do a translation first. So our first image, or our intermediate image, is when we do a translation. And so we take this and we slide it by some vector. So this is our original uh, translation there. Well, what if we let's do a translation second, since this one's the easiest one. So we have a second vector here. What is the final result? All right, if you think about it, a translation is two reflections. Another translation is two reflections. That's an even number of reflections. You're going to either end up with the identity. How could you end up with the identity? Well, if you have the vectors are just the opposite of each other. That'll put the final image right back where it started. So that's a possibility. Um, Otherwise, what you end up with in this case is another translation. And the vector for the translation is just the sum of the two original vectors, which you can see pretty clearly from this. So that's a pretty straightforward. And if you slide it and then slide it again, you could have gotten it directly with the slide this way by just vector being summing those two. Okay, what if you have a reflection second? So here's our final image here. So we translate here, then reflect that about this line. How does that one now? How does the original one compare to that? Well, one way you can find that is to look at those different midpoints. Okay. The resulting transformation, we see that those midpoints are in a line. That is the mirror line for a glide reflection. So the result is a glide reflection. We should have expected either a reflection or a glide reflection from this. Not a rotation. Okay. So let's take a look at this in a little bit more detail if we can. So notice that the mirror line for the glide reflection contains the midpoints of these line segments connecting up pre-image to image. This line segment is its midpoint. Same for the other points. This would be on no matter which points you pick here, they would be the midpoints of those little line segments would be on that same line. To go back and see what this would be, you could take the final image reflected over that mirror line to get this image here, connect from A to what I'm calling a triple prime here, and that will be your vector. And so you can see that here. Okay, so that's a translation, and then a reflection gives us a glide reflection. Translation, yeah, and a reflection. So the translation here and a glide reflection. Now, if you compare these two vectors, you can see that here's the mirror line for the second isometry, which is the reflection. If we if we resolve this vector, the original vector, into components parallel and perpendicular to this mirror line here, we get the parallel component is the vector for the glide reflection, and the perpendicular component, if you look at it, its length is twice the length between here and here. So if you do the components here, you're going this way and this way, and if you look, this this distance here is half of the distance here. Okay, so translation first, then a reflection gives us a glide reflection. Okay, so what else do we have? We have translation and rotation. Okay, so there's your translation again. And the rotation, there is the center of the rotation. We can control that. And then the angle there. Maybe I can control that. Something's a little bit out of whack there. What's the final image here? Okay, let's see what we might expect. Translations 2, that's an even. Rotations, also an even. We should end up with a single reflection, rotation, or identity, or translation. No, not a reflection. A rotation, translation, or the identity. Clearly not the identity, not a translation. This must be a rotation. Okay, so let's see if we can see that. If we take the line segments that connect pre-image to image, find their midpoints. Notice those are not in a line, but if we do the perpendicular bisectors, those do cross at a point. That will be the center for our rotation. Okay, a lot going on here. Let me see if I can get rid of some of that. So there is the final result is that. Notice that if you take half of this angle here, which is controlled by this slider here, that half of that is, let's see, no, it's actually not half. It's the same angle, isn't it? So the angle here is the same as the amount of the original rotation in this case. Okay. So the rotation amount is the same as the original, as the second, as the rotation. And let's look again. And the center has been moved a little bit. But the center can be found once again by taking the pre-image to the final image, finding the midpoints, do their perpendicular bisectors. That will go through the new center. All right, so now we've done those. Let's do one more. Translation followed by a glide reflection. Okay, so translation first. Okay, for our glide reflection, we have a vector where we slide this some way, and then we have a line that's parallel. So there's a intermediate image, and the final image then we get by reflecting that over the mirror line. So this gives us the, so translation first gives you this, glide reflection gives you the final image. Okay, let's kind of see what we might expect. Glide reflection, let's see, translation is 2, 2 reflections, and glide reflection is 3. That's 5. That's an odd number. We should see either a reflection or a glide reflection for our final answer. Okay, it looks like probably a glide reflection is what's happening here. So we can see that by connecting up pre-image to image points, finding those midpoints, which we can see here. Let me this a little bit easier to see. And one thing you notice about those midpoints is they are all on the same line. And that line will be the mirror line for your glide reflection. Hey, look at that. Notice it is parallel to the original line. Let's see if that holds. Yeah. So as you move this around, that it is the mirror line for the glide reflection, of course, is parallel to the vector for the glide reflection. And then this mirror line is going to be parallel to that mirror line. Okay, so one way we could find it is take the final image once we found these midpoints and make this mirror line, reflect it over to get this orange one over here, and then draw your vector from A to this A quadruple prime. And so the glide reflection slides to here, reflects over the orange mirror line, and gives you the final image here. So if we kind of take some of this away, here's your glide reflection. This one goes here, reflect over that, gives you this one here. Resulting glide reflection. Now, that we don't need. Okay, what else can we see here? The distance between these two mirror lines, let's see, we've got a translation first. If we take that translation and resolve it into parallel and perpendicular components to the mirror line for the reflection part of the glide reflection, then, or components in the direction, that's the same as in the direction of this vector, make it into components. Then we see that this vector here, the component in this direction, is actually, I think, the opposite of this one here. And the perpendicular one here is going to be twice the distance here. So I think, yeah, this one is here. So you can see that's twice. Some rounding off for the last digit's not lining up, but that's, so that tells you some of the relationships that are going on there. I encourage you guys to open up this GeoGebra sketch. As all my GeoGebra things, they're out in the public. You can get them directly from GeoGebra site by searching, but you can also open up my geometry workbook, which you can see here, Geometry Collected Resources. I've got all kinds of things that I've made and some other people have made. The transformation stuff is down here in chapter 15. Got some just on translations. Those look like things that other folks have made. Reflections here, rotations here, and then some of mine are here. And the ones that we're looking here are either in the more transformations or compositions. You'll see those. All right, so that covers all of the possibilities for starting with a translation and then following it by either a reflection, translation, rotation, or glide reflection. In the next video, we'll look at what happens if you start with the rotation, and we'll do another video to see what happens with the glide reflection. Okay, let's do a summary of this now. So if you start with the translation, and then the second one is a reflection, where the mirror line is parallel to the vector, you get a glide reflection. The vector is the vector from the translation, the mirror is the mirror line from the reflection. If you do a translation followed by reflection, the mirror line is not parallel to the vector, you get a glide reflection. The vector is the projection of the vector from the translation onto the mirror line from the reflection, and the mirror is parallel to the mirror line from the reflection. In the translation, the mirror line from the reflection by a component of the vector from the translation perpendicular to the mirror line from the reflection. If you do a translation followed by a translation by the opposite vector, you get the identity transformation. So the inverse of a translation is a translation by the opposite vector. If you translate something and then translate it again by a non-opposite vector, you're going to get a translation, and the vector is going to be the sum of the two original translation vectors. If you do a translation followed by a rotation, you get a rotation. The center is the intersection of the perpendicular bisectors of line segments from pre-image to image points, and the angle is the same as the original rotation angle. If you do a translation followed by a glide reflection, where the two translations are inverses, you get a reflection. The mirror line equals the mirror line of the glide reflection, and the mirror line includes the midpoints of pre-image to image line segments. If you do a translation and glide reflection, translations are not inverses, you get a glide reflection. The vector is the vector from the glide reflection plus the component of the vector from the translation in the direction of the vector from the glide reflection. The mirror is parallel to the mirror line. From the original glide reflection, the distance between the mirror lines is 1/2 the length of the component of the vector from the translation perpendicular to the mirror line. From the glide reflections, the mirror line includes the midpoints of pre-image to image line segments. So that table uh, gives us the summary of what we just saw. All right, see you next video for starting with a rotation.